Hi guys and welcome to Learn Extra Live. It is Maths Grade 10s and you should be joining in. And no, this isn't a new teacher, this is Rob. How are you, Rob?
I'm very well today, thanks.
Good, good. Okay guys, so Rob is from, let me show you this now, the World Education Games, which is a very, very exciting event taking place very, very soon. So I'm going to be doing a little bit of an interview with him too, but I've got Tamlin in studio too.
Hi everyone.
Hi Tamlin, how are you?
I'm well, how are you?
Oh, so good, so good.
Looking forward to a nice lesson today.
Can't wait. And I know that you have lots of questions for Rob as well.
I do.
But I'll ask a few ones super quick. So Rob, tell me, what exactly is the World Education Games and how can learners participate?
The World Education Games is a live, online, free event for anybody on the planet to take part. All you need to do is to go and register at worldeducationgames.com. You can register as a parent for your child, as an individual learner, or preferably as a teacher for your whole class and your whole school.
And this is where Tamlin's like winking her eyes and she's like, yes, yes. So when is this taking place?
The event is on the 5th, 6th and 7th of March, so it's a week tomorrow, but the practice or the warm-up period has started already. So you can register as soon as you're ready and you can practice for the next few days. And then on the 5th, we'll turn everybody back to zero and start from then.
Fantastic. So now this is the question. How do you register? And can a whole class register together?
Yes, it's preferable for a class to register because there are some class prizes. So as long as you've got 10 or 15 or 20 friends, you can get your teacher to register you together as a class. And once you're registered for one event, you are able to use the maths, the literacy and the science because it's 3 days rolled into one called World Education Games.
It sounds like so much fun. So now, also on this, what is the cost? And you said something about prizes. I know they're going, oh, what are the prizes?
Well, there's always prizes. There's prizes for the global winners. There's prizes for the South African winners, for individuals and for schools. There are medals that people can wear.
These are so cool, guys. Yeah.
Almost like the Olympics. You can win medals because we like to make mathletes out of you mathematicians because you're just as important as athletes are.
It's so true. And I know we've got a lot of mathematicians, especially here on the page today. I mean, I love this one. This one says maths, and guys, it's pretty heavy.
Indiana, may I interrupt for a moment?
Of course, of course.
Are the learners restricted to school time hours in order to participate, or can they do it at any point in the day?
They can do it at any point. Because it's a website, it's available 24/7 to anybody who has a username and password. You can use it at school, in the afternoon, on the weekend, or at home, anywhere that you like.
Fantastic.
And it is free. There's no cost to this at all.
Super, fantastic.
It's incredible.
I'm sure the learners will certainly look forward to that.
Yeah, I'm looking forward to it.
Absolutely,
Hey?
wonderful.
It's incredible. So now, how many learners participated last year, do you think?
4 million.
4 million, guys.
Around the world, and about 35,000, maybe a bit more in South Africa. So we encourage you to get online and register yourselves or get your teacher to do it. And it doesn't matter what age you are because when you register, you put in your age, and there's 4 categories. So you will put in your age and you will get age-relevant questions.
It's incredible. Okay, so now before we get onto the ambassadors, I just want to let them know again, guys, it's from the 5th to the 7th of March 2013. I will be posting this up on the Facebook page. I'll put all of the details you need there. So go to facebook.com/learn extra and you'll get everything there. I think any more questions, Tamlin, because I think it's very important to get this from a teacher's point of view.
About Maths Day. Well, let's have a look at the website. So we've got www.worldeducationgames.com. So that's obviously where everybody needs to go to register. And here are some pictures of the ambassadors. I'm sure, Rob, you could tell us a bit more about them.
The ambassadors.
Well, globally we appoint ambassadors to represent the World Education Games, also to try and raise some funds for UNICEF, which is the United Nations Children's Education Fund. And we have appointed 2 in South Africa. There are about 60 globally. So if you go to the website and you look at the ambassadors tab or the blog, you'll see reports from obviously our own ambassadors, but also ambassadors from Pakistan and Mexico and Canada and all over the world.
That's amazing. So maybe some of you guys, the mindsetters out there, would like to be ambassadors yourself. Thank you so much, Rob, for joining us. It was amazing, and I hope that all of you guys are thinking of entering. I will make sure that I put all of those details on the page. Any final last words?
Only to reiterate, get your teachers or your parents to help you register, or just do it yourself. And it's all free on that website.
Rob, one more question if I may ask. What is the youngest age that can register?
Age 4.
Okay,
Age 4.
fantastic. Super, great.
That's amazing. Okay, guys, so if you have any younger brothers or sisters, age 4, you can enter them too. We're going to go to a quick break, and when we get back, we'll be going over your maths questions, grade 10s. Get those pens and papers out. Let's get ready to learn more, learn extra. See you now after the break. Hi guys, and welcome back to Maths Grade 10s. As you can see, we've got yet another addition to the studio. I've got Looney, one of our top 10s.
Hello, mindsetters. How are you doing today?
We're doing good, thanks. And you, Looney? How are you?
I'm very good, thank you.
Oh, good. Okay. So now, guys, if you missed her audition tape, I think it's about time that I ask her a little bit about something about herself. Tell the mindsetters a little bit, something interesting.
Well, I'm just a loving person. I'm very fun to be with. I'm very loud. I love people. I love talking. I'm just a fun person to be around.
Yeah, and we can't wait, because that's what we need, especially as a social media presenter. She needs to talk to you guys a lot. So tell them, where can they find us on Facebook?
Well, on Facebook, you can go to facebook.com/learnextra.
Do you know the Twitter handle yet?
At Twitter, we are on @mindsetlearn.
Oh, no, it's at Learn.
At Learn Extra. Sorry.
You knew that. You knew that,
Of course
though.
I did, you know.
Okay, so now, guys, what we're going to do is I'm going to hand it over to Tamlin, because at the end of the day, this is a math show. What I need you to do is post questions on our Facebook page. It's facebook.com/learnextra. Post them there, and Looney will be here to help you out. Okay, so I think, Tamlin, it's time. Take it away.
Thank you so much. Right, grade 10s, I hope you're all ready for a lesson on equations and inequalities today. So let's have a look at what we are doing here today. In our lesson, just to have a quick look at our lesson description, okay, we're going to be having a look at linear equations. And just to give you a very brief description of those, if we are solving a linear equation, we're solving for one value for x, or whatever that variable may be. It doesn't have to be x, so just remember that as far as an equation goes. We're solving for the value of a variable. Very often it is x, okay. So we're looking for one value of x, and that's what we're doing in a linear equation. What we're going to now do is, when we talk about our equations, we're going to introduce fractions, okay? Those are always everybody's favorite. I know everyone loves their fractions. And first of all, we're going to be having a look at it with a numerical denominator, which really just means we're going to be solving an equation where there are numbers in the denominator. And then we'll have a look at algebraic denominators, where we have x's or whatever variables we're working with in the denominator. So we're going to be having a look at those, and those become very important to us, especially this year and going on from here to next year as well. Okay. Once we've had a look at our linear equations, we're going to look at linear inequalities. Remember, guys, that our inequalities are defined by our greater than or our less than signs. And so we're not just talking about one specific value for x, we now talk about a whole range of answers for x, okay? And finally, once we've done that, we then look at something very interesting called a simultaneous equation. Now, what that involves is if we've got two equations with two different variables, okay? We use a simultaneous equation to help us find the value of both of those individual variables in each of the equations. So we've got lots to get through today, so let's not waste any time. Let's get going with our quick, at our key concepts, okay? Very quickly, let's have a look, grade 10s. When we're solving a linear equation, it involves finding only one value for x, as we said, and essentially the point of an equation is to make sure that the left-hand side is equal to the right-hand side. When we're solving a linear equation with fractions, okay, we always go about finding the lowest common denominator, and we apply our golden rule of fractions in that what we do to the denominator, we do to the numerator. So to put it into easier language, what we do to the bottom, we do to the top. I'm sure we all remember that from years gone by. Okay. When we're working with the lowest common denominator, just to have a look at over here, the variables. Oh, with variables, yes, we need to state a restriction. I'm going to explain that later as we go through an example. And then we talk about inequalities. Yes, okay, so inequalities, just to summarize it, guys, we're talking about an inequality, which means that we are referring to a whole range of values for x. The difference between an equation and an inequality is that an equation gets one specific value for x, particularly a linear equation. We just get one answer. A linear inequality, we get a range of answers on our number line, either greater than or less than a particular point on your number line. Okay, guys, let's get on to some examples. And let's actually put this theory into practice. Okay. First thing we know about any equation, your instruction is always going to be solve for x, okay, or solve for whatever the variable is. So let's see what we've got over here. I've got a 3 minus 2y equals 6y minus 1. Now this is relatively straightforward for us in grade 10. We need to gather all of our variables to the left-hand side. Now remember, the idea is that to eliminate the 6y on the right-hand side, I'm going to subtract a 6y. But the theory is that whatever gets done to the left-hand side of an equation must get done to the right-hand side, because we need to make sure that it is always balanced. So as a result, we minus 6y on the left-hand side over there. We've got negative 1, which is already on the right-hand side. And in order to get rid of positive 3, we minus 3, and so therefore we do it on both sides of our equal sign. All right, so therefore we've got negative. I've got negative 8y, which is equal to negative 4. And when we divide by negative 8, we get our answer for y, which is just positive a half. 4 over 8 will simplify to a half. Negative over negative, just remember, we'll make positive. Okay, so that was a good start. Not too difficult to start off with, but we're just getting our brains going here. Okay. Right, let's have a look at one that involves a little bit of distribution. Okay, just taking it one step further. So let's have a look at this example over here. We are now being asked once again to solve the equation, and we've now got a sum where we've got brackets. Okay, so you want to get rid of those brackets. I think we all agree we need to eliminate the brackets, and in this case, the way we are going to do that is by means of distribution. I'm going to distribute my 7 into the first bracket. For the second bracket, grade 10s, please watch out that it is not just 2 that is going into the bracket, it is negative 2. So the negative 2 is going to distribute into both terms of that bracket. And then this negative 2 for now is just sitting on its own, so we do not do anything with that just yet. So 7 times by x is going to give us 7x. I've got 7 times by negative 2, which is negative 14. Negative 2 times by 7 is negative 14. And negative 2 times by negative 3 is going to give us positive 6. And there's my minus 2 that is sitting on its own at the moment. Okay, let's gather like terms. I've got a 7x and I have got a 6x, and that is going to get us to a 13x, okay? Let's add our whole numbers. I've got a negative 14 minus another 14, which would give us negative 28, minus another 2, which would give me negative 30, which is equal to 0. And now we need to gather terms with an x on the left-hand side and terms without an x on the right-hand side. And to get x on its own, because remember that's the point of any equation, we're solving for the variable, x is equal to, this over here is not going to give us a particularly nice answer, but 30 over 13 is going to be the solution for x. That will make our left-hand side balance with our right-hand side. Remember, guys, the point of an equation, and something you can remember for yourself, if you get an answer for x and you substitute it back into the original sum, what we should always land up with is what the left-hand side and the right-hand side look like should be exactly the same. So that's, remember, what we're trying to do with an equation is to get them to be balanced. So if you ever want to check yourself, that's how you're going to do it, okay? Okay. Let's have a look at one now. We are still going to have to get rid of brackets. Okay, that's for certain. But this one involves a little bit more working out, because what we can see here is I've got a binomial multiplied by a binomial. I've got a binomial, which is being squared, and I've got another bracket over here, which is going to have to be distributed. So before we even consider the option of solving for x, we need to get rid of those brackets. We don't want to do anything yet until those brackets are gone. Okay, so guys, let's have a look at what we need to do. The first bracket over here is going to be simplified by means of FOIL. Remember, FOIL is how we multiply out our first two terms in each bracket, the outer two terms in each bracket, the inner two terms, and the last two terms. Okay, so that's what our FOIL stands for. Please, I'm going to put a big NB over here because, guys, lots of you make this mistake over here. You've got a binomial that is being squared. Now, let me show you what the typical mistake is, and hopefully you are never going to do this. Okay, this is what a lot of people make the mistake of doing. They think that we're going to take squared, and we square the first term, and we square the second term, and we think that the answer is 9x squared plus 4. That, grade 10s, please, is a big, big no-no, okay? You are not allowed, because you've got two separate terms inside that bracket, you are not allowed to just distribute that 2 to both terms. If we think about it logically, what is this saying? If I've got 3x minus 2, and it's being squared, anything that's being squared means we're multiplying it by itself 2 times, okay? So if we applied that theory, that would mean that I'm multiplying the bracket of 3x minus 2 by itself 2 times. And can you guys see that, in fact, now we would have to then apply the theory of FOIL as well. So grade 10s, it's really just a word of warning to you guys. Please watch out for that mistake. It can be very costly in your tests and exams, and I know I've seen that mistake happen before, so just watch out for it, okay? All right, let's take this all away so we can actually just work out our sum nicely. And let's see what we've got here. Right, so if we FOIL out the first 2 brackets, we're going to get an x squared. I've got outers, which is going to be positive 4x. I've got inners, which is negative 3x. And I've got lasts, which is negative 12. Then I have got minus. Okay, now here's another thing to watch out for. This negative is being multiplied to that whole bracket squared. So we are going to have to first square the bracket out, and once we have done that, then you are going to be able to distribute the negative. Okay, so just watch out for your order of operations. All right, good old BODMAS. Let's FOIL this bracket out. So if we're FOILing it out, we're going to land up with 9x squared minus, okay, I'm going to do it in 1 step over here. If you need to take 2 steps, that's absolutely fine, and plus 4. Okay, so what I've done is FOILed it out. Okay, and forgive me for writing it on 2 lines, but I've run out of space there. What we've got over here now is x minus, okay, now I've got a negative 8x, which is going to have to distribute into the bracket. So it's going to have to be negative 8x squared plus 8x. Okay, right, so we've got a little bit of tidying up to do over here. No good leaving it like that. We need to still get rid of brackets, and we need to add all our like terms. So let's get rid of those brackets and add our like terms, and then I'm sure it's going to look a lot simpler. So let's see what we've got. I've got my x squared plus 4. Let's add these together. 4x minus 3x is going to leave us with positive 1x minus 12. Now what we're going to do is distribute the negative into that bracket. So I've got minus 9x squared. I have got plus 12x, and I have got negative 4. Right. On the right-hand side, let's just quickly put them together. I've got like terms over here. So I've got 1x plus 8x, which is going to get us to 9x minus 8x squared. Okay, guys, so looking a bit better, but we do still just need to tidy up a little bit more. So let's see what we've got here. I've got an x squared minus a 9x squared. That's going to give me a negative 8x squared. I've got an x plus 12x, which is going to give me 13x. And I've got a negative 12 minus a 4, so that is giving me negative 16. Okay. Right, what I'm going to do in the same step here is I'm going to bring my 9x and I'm going to bring my negative 8x squared over to the right-hand side. And in so doing, that will make it negative 9x. and positive, sorry, let's get rid of these arrows so they don't confuse matters, and it will become positive 8x squared. Now, I'm sure you guys are sitting and thinking, hang on a second. So far, we've only ever solved for linear equations. We've never seen an x squared before, all right? And you're right. Up until now, you absolutely haven't. And in fact, what happens in this case is that the x squareds cancelled each other out, so they're gone, okay? 13 minus 9, that's going to leave us with a 4x. And if I bring my 16 over, x is going to be equal to 4. So it worked out quite easily. It was just a whole lot of simplifying, okay? Right, I'm sure we're due for a short break.
Let's do that. And as you can see, Looney is busy away, writing back to all of your comments. Guys, so please post those questions or comments. Let us know how your day is going on facebook.com/learnextra or on Twitter @learnextra. We've got mistyping fingers here behind the screen. See you now after the break.
Welcome back, grade 10s. It is maths. It's a Monday, so Maths Monday for grade 10s. Right here, Indy, what do we have?
Deliciousness. That's exactly what it is. Simba have sponsored us this awesome Cheetos pack to give away to the mindsetters that post their random act of kindness. So now how they do it, Looney, is they post it onto our events page. It's called Pay It Forward. And all you have to do is it can be a picture, it can be a video, or we've started saying, or you can just let us know what you've done, which is a random act of kindness.
Okay.
You know what? It's not about big things, about spending money and you know, doing those things. It's about the small things. It's about helping.
Giving off your time and all of that.
That's exactly what random act of kindness have you done
Well,
recently?
actually today, you know what I did? I was at the square here at Randburg, and then I was just passing, and I saw this blind man with a tin. So I'm like, okay, I just passed, and then I just looked at him, and my heart just sank. I was like, okay, no, I just have to go put in some money for that guy. So I took out a little bit of money that I had, and I put it in his tin, and I could see that he was so grateful for what I did. And I was just imagining, there were so many people passing him, you know, not paying any attention to him, and I was like, I actually made his day by giving him that money that I had. Yeah, so
That is. It's a random act of kindness, guys. It's that small second. On Saturday I was in traffic and I saw the person in front of me give the guy some change. So I thought, oh, okay, let me give some change as well. And I gave some change. And then I saw all the cars behind me actually ended up doing it too.
and it's so easy to take those things for granted because you don't even know what those people go through, but just giving them that money makes a difference, you know.
Exactly. Okay, guys, so post that on our Facebook page, facebook.com/learnextra. Pay it forward, random acts of kindness, and you could stand a chance to win this awesome hamper from Simba of Cheetos, a Mindset tee, 5 CDs, guys, not just one, but 5, Mindset lanyards, and as well as a Simba notepad, a Cheetos
cool is
notepad.
that?
It's awesome. So now I'm going to send it straight back over to Tamlin. Don't forget, if you have any questions, please post them on the page here. We are here to help you. Use Tamlin as your own personal couch teacher because they're all sitting there on their cell phones, Facebooking on the couch.
Absolutely. In fact, I was just about to suggest a random act of kindness would be to assist your fellow learners on the website.
That's
If they-
brilliant.
If they're struggling with their equations and you've got it under control, you know what's going on, help them out. Absolutely. That's a good act of kindness as well. Okay, let's have a look over here, guys. Now we're going to introduce fractions. Okay, so please don't fear the fractions. It's not necessary. They really are friendly.
This is where we start to sweat. It's like sweating.
Absolutely. And in fact, there really is not much to it. So if you understand the concept and you're just careful with your working out, there is no reason to have a problem with fractions. So let me show you how it's done. Okay. We have got an equation of 2x minus 1 over 3. I've got minus 3x plus 2 over 6. And it's equal to x over 2. So what we have over here is numerical denominators. So all the denominators, the numbers at the bottom, are all numbers. Okay, so this is still in fairly sort of easy territory. We don't have any variables in the denominators just yet, but let's have a look and see what we can do here. Right, guys. The first thing we have to do is find the lowest common denominator. Remember, you are adding and subtracting fractions, and we learned way back when that when you are adding and subtracting a fraction, we find the LCD. And when we're finding an LCD, our golden rule being what we do to the bottom, we do to the top. So those rules never went away. They're still there. We have to apply them. Okay. I've got a denominator of 3, I've got one of 6, and I've got one of 2. So the idea is, what is the smallest number that 3, 6, and 2 can all go into? And I'm sure you're all shouting it back at me right now. It's 6. Okay, so our lowest common denominator is going to be 6. So therefore, what we're going to do is let's give ourselves a line. And we're going to say equals, and we've got another line over here. And we're going to put everything over the LCD of 6. Okay, so what did I times 3 by to get to 6? I had to multiply it by 2. And the rule is, what we do to the bottom, we do to the top. What did I times 6 by to get to 6? Well, I multiplied it by 1. And what we do to the bottom, we do to the top. And what did I times 2 by? I times it by 3. And what I do to the bottom, I do to the top. Okay, so this 2 needs to distribute into my first bracket. Now, here's something to watch out for, guys. Can you see that this is not just 1 that is going into the bracket? There is, in fact, a negative 1 attached to it. Okay, so watch out. This is something that you could have a problem with. If there's a negative there and 1 is getting distributed, don't forget that the negative does go with it. Okay, so therefore we're going to distribute negative 1 into the second bracket, and obviously 3 and x will just get multiplied on the other side. So what does that give us? We've got 4x minus 2 minus 3x and minus 2. Do you guys all see where that negative came from? A negative times by a positive gave me negative. And I've got a 3x over here. All right. Right, here is the nice part about equations, but please remember this. It only works for equations, okay? I don't want you now suddenly to go throwing your denominator away every time you see it. It only applies to fractions, and this is our rule. If we have got an equal sign and there's a lowest common denominator on either side of that equal sign, if I were to get rid of 6 on the left-hand side, I would multiply it by 6 on the right-hand side, and vice versa. If I was dividing by 6 on the right-hand side, I would times it by 6 on the left-hand side. And what happens is they really just cancel each other out. Okay. So therefore, when you have got a lowest common denominator on either side of your denominator, that denominator will fall away. Okay, it cancels out. All right. So as I say, guys, please watch out. That doesn't mean you throw your denominator away every time you see it. It's only in an equation. All right. Okay, so now that we've got that, I've got 4x minus 3x, which is giving me 1x, and I've got negative 2 minus 2, which is negative 4, and I have got 3x on the right-hand side over there. So if I now do a swap around, to get rid of my negative 3 on the right-hand side, I am going to subtract it on the left-hand side, and to get rid of negative 4 on the left-hand side, we're going to make it positive 4 on the right-hand side. Okay, and that leaves me then with negative 2x, which is equal to 4, and x is equal to 4 divided by negative 2 is negative 2. Okay, so the value for x that when we substitute it back into the original equation would make the left-hand side equal the right-hand side is negative 2. Okay, so you can see the fractions are not so bad. You just got to remember lowest common denominator. What you did to the bottom, you do to the top. And once you have done that, you are allowed to get rid of your denominator. Okay, that denominator falls away. All right. Okay, so now that we've got that under control, let's have a look at one where there's a little bit more involved, because now what we've got is algebra in the denominator. Will the rules change? Will the steps change? Absolutely not. We just have to be a bit more careful with what our LCD is. Okay. All right, guys, so let's see what we've got over here. I've got an x minus 2 in my first denominator. I've got just an x in the second denominator. And then I've got a bit more of a complicated looking one. I've got x squared minus 2x in the third denominator. Right, first things first. you want to get the lowest common denominator. That's what we're aiming for. So therefore, in order to do that, we need to try and simplify this a little bit. We don't want to leave it as x squared minus 2x. There's too much involved there. So what you need to do, guys, is you need to factorize it, okay? So we need to factorize this denominator. Okay, so first step is going to be 4 over x minus 2 minus 10 over x, which is equal to 2 over. Now, if I were to factorize this, the first thing we always look out for when we're factorizing is a highest common factor, which in fact we do have. It's x, which is going to leave me with x minus 2. Now, if we look at this, suddenly I'm hoping you're looking at it and thinking, okay, hang on, that makes it look a little bit easier, because if we're looking for the LCD, let's see what's common. So let's see what's common. Let's use a different color. I've got an x minus 2 in my first denominator, and I have another x minus 2 in my third denominator. So if we're looking at lowest common denominators, a bracket of x minus 2 is covered there and there, all right? Then I have a value of x in the second term, and I've got a value of x in my third term. So therefore, that value of x also needs to be part of the LCD. So that's your lowest common denominator. We've got our x, and we've got our x minus 2 in brackets. Okay, right. So now let's apply the rule to get the LCD. What we do to the bottom, we do to the top. Okay. Right, so my LCD is x minus 2, and x minus 2. Okay, what did I multiply x minus 2 by to get the LCD of x minus 2? Well, the bracket of x minus 2 is already there. What we're missing is just the individual x. So therefore, we needed to multiply that by just x. This x over here is missing the bracket of x minus 2. And this 2 over here is in fact already over both the x and the x minus 2, so we don't need to multiply it by anything, or if anything, 1. Okay, so we can say multiply it by 1. Okay, so therefore that leaves me with a 4x minus, now remember this is going to distribute, so I've got minus 10x, and a negative times a negative is positive, and 10 times 2 is 20. And on this side over here, we've got a 2. Okay. Right, who can remember what we have to do with our denominators? We can get rid of it. Okay. But guys, here is something you need to watch out for. All right? When we have a variable in the denominator, let's think about this for a second. There would be 2 numbers for x that would cause a problem for us here. The first one would be 0. Okay? If x was equal to 0 in that denominator, remember, anything multiplied by 0 is 0. So if that value for x was 0, the whole denominator would be 0, and that would be a problem because then it's undefined. So therefore, we have what we call a restriction, okay? And we have a restriction, which I'm going to write on the side here. And the restriction is basically what is x not allowed to equal? Because if it's equal to that certain value, the denominator would be undefined, okay? And the first value is that x cannot be equal to 0. Okay, that's the first one. And the other one would be this. Let's have a look at this bracket. If I had, what value for x would make that bracket equal to 0? Okay, I think you guys agree it would be positive 2. If I had positive 2 minus 2, I'd get an answer of 0. And again, that would make my denominator undefined. So there's another restriction, and that is that x is not allowed to equal positive 2. Okay, so guys, this is what we have to do now. We're going to solve for x, and once we have solved for x, we're just going to double check that neither of my answers actually matches a restriction, because if it does, then we're going to have to say, well, hang on, that's not going to work, and it makes it a non-valid solution. Okay. All right, so at this point now, we can drop the denominator, and we're left with just 4x minus 10x is equal to, and let's make this 2 minus 20. Okay, so we're going to get negative 6x is equal to, and that's going to leave me with negative 18, which when I divide by negative 6, my answer for x is equal to positive 3. Does my value for x match either of my restrictions? No, it doesn't. So therefore, can we say it's a valid solution? We certainly can. Okay, and valid meaning that if I substituted my 3 back into my equation, everywhere you saw an x, the left-hand side will equal the right-hand side. Okay, so I hope you guys understood that carefully. Go over it again because it's one of the it's your more difficult equations dealing with the algebraic denominator, but difficult not so much because all we have to make sure we do is consider the restriction and then just make sure we carefully work with our lowest common denominators. So go and practice those, please, grade 10s, because they are important, and as much for this year as for next year as well. Okie dokes. Right, I want you very quickly, before we go on an ad break, to write this example down for me. And while we have an ad break, I think a good idea would be for you guys to get a head start on it. So let's have a look. It's 3 over x minus 6 minus 5 over 2x minus 8, and it's equal to x minus 24 over x squared minus 10x plus 24. Right, grade 10s, I would really like you to give that a try while we take a short break and see how far you get with it. I'll be very interested to see if you guys manage it on your own. So give it a try.
Okay, guys, we're going to go to a break. Looney, what's happening on the page?
Well, we've got some people giving us some positive things here. One, Patu Mudao Mukwebo says, wow, guys, we should have grade 10 maths time more often. He's enjoying this. And then we have, I can't pronounce his name.
I think it's Godstein.
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 Wow. He says, you guys are great. Love that. Teach more. We are learning our today's leaders. Guys, thank you very much for the positive responses. Keep commenting on our Facebook. We'll post everything, guys. We will check them. We'll be back for a short break after this. Welcome back, guys. You're still doing grade 10 maths. Please do not forget to go onto our website on Facebook. It is facebook.com/learnextra, and hit us up on Twitter as well. We are there. Our handle is @learnextra.
It's too quiet, eh?
Too quiet,
Where's
guys.
all these, what do
Your
we call
tweets.
them? The tweet.
Where are the
Twitterverse.
tweets?
Where are your tweets?
And don't forget to download your notes on learnextra.co.za/live. Over to you, Hamlet.
Thanks so much. Right, okay, let's go through this example over here. I hope you've had a few minutes to have a look at it, and if nothing else, had a little bit of a head start on it. So let's have a look, guys. What did we have to do? I've got a denominator of x minus 6. The question you need to ask yourself is, can you factorize that any further? And the answer to that one is no, you can't. Okay, so this one is going to stay 3 over x minus 6. I've got minus 5 over, and here, if I was able to factorize it, there's a highest common factor of x minus 4, well, highest common factor of 2, which leaves you with x minus 4. Okay, so I hope you guys saw that. I've got a numerator of x minus 24, so that's going to stay as is. And here what we've got is a trinomial, okay, a good old trinomial, which we're going to break up into 2 separate brackets, okay? If I take x squared, I'm going to put it into each bracket, so therefore I've got an x and an x. And remember the story, we're looking for factors of 24 that are going to help me get the number negative 10. So let's think about factors of 24. I've got 24 times 1. I've got 12 times by 2. I've got 6 times by 4. And I have got 8 times by 3. Those are all my factors. So looking for, okay, now here we've got to be careful because in fact, a 12 and a 2 can get you to 10, and so can a 6 and a 4. So in fact, this is a good example to show you that you have to watch out for the signs as well as the numbers, okay? So let's have a look here. We want a negative 10 in the middle. But bear in mind that we need a positive 24 at the end, okay? Now, in order to get a negative 10, I would need to have a negative 12 and a positive 2. But the problem there, guys, is that negative 12 times by positive 2 would be giving you a negative 24. And that's not what we want. We wanted a positive 24. So therefore, what we've got to consider then is that if I'm looking for a negative 10 using the factors of 6 and 4, negative 6 minus 4 gives me negative 10, and negative 6 times negative 4 gives you positive 24. So there we go. Those are the factors that we are looking for. So what I'm going to have is a negative 6 and a negative 4. Okay. Now remember, the point of doing that is we're trying to find a lowest common denominator, something that's simple. So I've got a bracket of x minus 6 over there, and I've got a bracket of x minus 6 over there. So that is going to be the first part of my LCD. I've got an x minus 4 and another x minus 4, which means that's going to be the next part of my LCD. And we also have a 2 outside there. We can't forget about him. So that's then our lowest common denominator. All right, so now what we are going to do is we're going to put everything over that LCD, and what we did to the bottom, we all know the story, what we did to the bottom, we're going to do to the top. Okay, so this is my LCD, 2x minus 4, x minus 6, as well as on this side, 2x minus 4, x minus 6, okay. This 3 was only over the x minus 6, so therefore this 3 needs to get multiplied by the 2 as well as the x minus 4. Okay, I hope you guys see that. Please take note, guys, that that is a negative 5. It is not just positive 5. And it's already over the 2, and it's already over the x minus 4. So what it needs to multiply by is the x minus 6. Right, that is the left-hand side of the equation. Now let's have a look at the right-hand side and see what that's going to be. I have got my x minus 24, and that x minus 24 was already over both the bracket of x minus 6 and x minus 4, so therefore all it needed to be multiplied by was a 2. Okay. Right, I want you, before I finish this sum, very quickly, because we have to do this fast, I want you to email through or Facebook through to us and tell us what are the restrictions to this denominator. What would I have to be careful that x is not allowed to equal, because it would actually make the whole denominator undefined. So off you go, guys, get Facebooking. Okay. Right, what we do know is that we can cancel those denominators. Okay. And now we're going to multiply. 3 times 2 is 6. Okay. So therefore, when I distribute my 6 into my bracket, we are going to get 6x minus 24. Negative 5 is going to distribute into my bracket, so we get negative 5x plus 30. And on this side over here, 2 is going to distribute. It's just coming from the other side, but it works exactly the same way. So 2x minus and 24 times by 2 is 48. Okay, so let's add like terms. 6x minus 5x is 1x. Negative 24 plus 30 is going to leave us with positive 6. And on this side, we've got 2x minus 48. Right. Let's bring our 2x to the left-hand side, which is going to make it negative 2x. And if I've got negative 48 on the right-hand side, 6 is going to come over to join it, and it will make it negative 6. Okay. Therefore, leaving us with negative x, which is equal to, now this gives us a big number, negative 54 should be our solution over there. And we're going to divide by the negative to make it positive 54. Right, I think we're safe to say that our denominators wouldn't match the actual value for x. However, did anybody manage to send down any answers through, Indy?
Well, we've got Nicola. She says x is equal to 54.
She's absolutely right. And did she state
Well
any
done.
Well done. Did you state any of the restrictions?
No, she didn't state any
Okay.
restrictions.
Just to watch out, remember the restrictions is what is x not allowed to equal, because it's going to make the whole denominator 0. Okay, look at your LCD. Let's just rewrite it over here so we don't look squashed. We had a 2, we had an x minus 6, and we had an x minus 4. Right, what were the values that would have made this denominator 0? The first one would have been if x was equal to positive 6. Because if that was 6, 6 minus 6 is 0, and anything times by 0 is 0. So just that little value of 6 would have made the whole denominator undefined. And the other one is that if that's a x minus 4, if that value for x was a positive 4, it would have exactly the same effect. It would make the denominator 0, and it would be undefined. Okay, so well done for getting that answer right. That's fantastic. Well done. And just remember to watch out for those restrictions. Okay. Before we go, guys, I would like to very quickly have a look at just an inequality, just to quickly compare the difference, okay? Remember we said equations, we're getting a value for x, and inequalities, we're getting a range of values for x. They get solved very, very similarly, okay? The only thing to watch out for is when you divide by a negative. So let's see if this example actually has something like that. To solve for x over here, once again, we're going to have to get rid of a bracket, okay? So 4 times 2 is going to give us 8x, and 4 times negative 1 is negative 4, and that's greater than 5x plus 2, okay? Very similar to an equation, we're going to gather our variables on the left-hand side and send our whole numbers or our constant terms to the right-hand side. So I'm going to keep my 8x on the left-hand side, 5 is going to come over to join it, and I've got 2 on the right-hand side, 4 came over to join it, so therefore making it positive. So that's going to simplify to give us 3x is greater than 6, and if we divide by 3, we get an answer that x is greater than 2. So guys, you agree with me, we're not just having one answer for x here. We're saying that as long as your value for x is something bigger than 2, your left-hand side and your right-hand side are going to be valid, okay? Everything on the left-hand side will always then be greater than what's on the right-hand side. So with an inequality, please remember that we actually always represent an inequality on a number line. Okay, so we take 2, we mark 2 on our number line, to indicate that it's not included, because just bear in mind, if it was included, it would have a line underneath your greater than sign. But it doesn't, so therefore we're saying that it's not included, and x is greater than 2. So therefore our values for x are everything greater than 2. Okay. Grade 10s, that brings us to about the end of what we can do today. No worries, we're going to carry on with this next week. So what we didn't manage to cover today, we certainly will do so next week. So make sure you are with us on Monday next week, and we'll go over simultaneous equations, as well as get a bit into our quadratic equations. So I look forward to seeing you guys then, and until then, next week.
I can't believe it's the end already.
I know.
And you, Looney?
I can't believe it.
Too
Kate.
fast, too
Can't
fast.
believe it. Well, thank you very much, grade 10s, for joining us. Grade 11s, it's you and up next. So grade 10s, same time, same place next week will be your turn again. But from us, until then,
Goodbye.